So let's get going. In the recent past, I did a webinar on AI for mixed model line design. And so I wanted to kind of complete the picture by spending some time talking about AI for mixed model material flow. We always like to say that the process of implementing or improving a value stream is like the two wings of a bird. So you need line design, or another way of saying that is workflow design. So tack time, standard work, line balancing, all those things. And then you have the other wing of the bird, which is delivering the parts, right, to the value stream so that if you're building a product, you can do the work. So if you don't have both of those functioning well, then you're going to have an obviously sub-functioning process. So let's spend some time in this webinar talking about material flow. Now, the other thing I'm doing differently in this webinar is I'm trying to focus very much on things that you could do today, as opposed to things that are theoretically possible, but you could never do it without some kind of, massive technical help. And I'm making that change because I noticed when I was doing some queries with, say, ChatGPT or Claude and asking for suggestions for ideas, I was getting ideas that sounded great, but I realized that they really wouldn't be implementable very easily. Although technically feasible, not easily done. And so I resubmitted my question to ChatGPT or Claude AI. I said, look, don't give me any ideas that are not native, that I couldn't just kind of do it myself without having a development team, without having a software development group to help and essentially writing a new app. And so I got better results doing that, I think, got more practical results. And that's what we'll see in this presentation. In terms of myself, my name is Richard Rahn. I'm a co-founder and principal with the Leonardo Group Americas. And in terms of my qualifications for talking about the subject, number one, I have a CPIM from APIX, that's Certified in Production and Inventory Management certification. So got that a long time ago. And I was a former material manager for an aerospace company for a good part of my career. But when I got into lean consulting in around 1994, I've been teaching the subject since that time. So it's been 30-year anniversary, if you can believe that, 30-year anniversary of teaching material flow subjects and workshops. And we were invited in around 2010 to teach our material flow workshop at Toyota Material Handling, not to the Toyota people, let me be clear about that, but to other companies. So they were willing to share their training facilities, do factory tours and help us with this, but we're actually training other outside companies to come to the Toyota factory and get trained in both line design and material flow. And the picture I'm showing you here is, you look at the date there, if you can see it on your screen, it says August 7th, 2024. So that was 2 days ago. So this is our current class. They're there right now. I just got off the phone before the webinar with Gerard, who's over on the left side of the picture there, about how things were going. But today's the third day of the line design class. So we've been doing this for quite a long time, and I was the principal instructor. So I spent a lot of time in Toyota, although never as a Toyota employee, but inside the factory, and rubbing elbows with all the Toyota folks for many, many, many workshops there, many weeks of my life. And then finally, we have a book that's going to be formally published. It's kind of in review stage right now, but it's going to be formally published this year, as soon as we can get it finished, called Material Flow. So I think I have a good enough background to be talking about some of these issues. I hope you agree. So our agenda for this webinar, we'll start with some definitions for those of you that might be new to kind of what we're talking about here. So MMMF is mixed model material flow. And then we'll also define this very important term for material management called PFEP, or plan for every part. Really important concept, kind of a foundational tool or concept that we use. And then we'll talk about automation, not so much AI. I said AI here, but really automation in material management or material flow, current state. Where are we today? Basically not including AI, kind of what tools are we using today? And then we'll talk about opportunities today. Again, to repeat, these opportunities are things that you could do today with a little bit of expertise, kind of like no coding options that you could use AI for to improve your material flow management. And then we'll do a little bit of speculation on the future. Now, the future is wide open, so we could spend a lot of time speculating about things that could be happening. So I tried to keep my speculation pretty close to things that are actually in development, but they're not quite ready for prime time, but that we have a high confidence are going to be happening here in the next, say, few years. Right, so I think this is going to be great. Really exciting topic. Thank you for joining me, and let's get going. So let's start with the definition: material flow. What do we mean by that? And especially mixed model material flow. So simple definition is it's a system, material delivery system, designed to manage the delivery of materials in an environment where you have a lot of different products, different options, a lot of variety, in other words, in order to ensure that your production lines or your value stream can actually run without delays, without waiting, without blockages. And so this aspect of mixed model manufacturing is critical in order to maintain the even flow, especially with a special focus on high variability or high mix kinds of environments. And that's not as weird as it may sound, because most of you or most of us in manufacturing are that kind of manufacturing company, where you have a lot of different models, similar but with differences that you have to accommodate. It could either be a lot of different base models, that's an option, or it could be fewer base models but a lot of different options on top of it, all of which, or both. Right? So all of that has to be managed, and if you don't do that well, then you're asking for trouble, because you're going to be either wasting a lot of resource delivering parts in an inefficient kind of way, or you're going to be stopping the line, right, for part shortages or having to reschedule. So those are all common things that happen, and we want to do the best job we can addressing those challenges. Next thing, quick definition of PFEP. So some of you may be familiar with this already, but basically what we're talking about here is a way to have a view of everything related to a part, an individual part that we might want to know about, and have it delivered to us, usually on a screen, but delivered to us in a format that's easy to understand and easy to sort and easy to filter and use as a really practical tool. And I say that because most manufacturing companies, if not all of them, have some kind of material management system, inventory management system, MRP system. Probably the best known one is SAP, Oracle. There are literally dozens, or maybe more than dozens of choices for MRP, ERP systems. But the problem is that even if all the elements that you want to know about a part are in that system, they're usually not in one place. They're usually scattered across different modules. And so it's very hard sometimes, unless we do something about it, to really get a snapshot of a part and really be able to see the inventory levels, the conveyance methods, the Kanban, strategy, the commodity code, the ABC code, the supplier information, usage, a lot of elements that we want to see, ideally on one screen or on one spreadsheet of some kind. So the typical tool that we use for this is Excel. Now, we're not saying that Excel is your repository. It's not the truth. The truth is in your ERP system or MRP system, but Excel is useful as a PFEP tool because it's something we're familiar with. We can sort it, we can filter, we can do a lot of good things with it very easily without requiring the intervention of the IT department to help us. Okay, so that's Plan for Every Part. Setting up essentially, if you want to think of it this way, a massive spreadsheet with lots of parts, in fact, all parts manufactured and purchased, and then across the columns, lots of different data elements. Okay, before we continue then into the body, let's do a poll, a little survey. I'm going to start it here. It's just for me to get some idea of your background using an AI tool like ChatGPT or Claude, large language models. So I'm asking you some simple questions. Some of you, one option is none, never used it. Another option is I kind of played around with it. A third option is, I do use it on occasion. Or last option is I use it basically all the time, right? Basically just about every day. Okay, so the numbers are jumping around here, but some of you, about a third of you so far, have never used it. So there is a free version, so you don't have to pay for it. I would really suggest getting your feet wet and going in and setting up an account with OpenAI and playing around with it. It's quite amazing. And it won't cost you anything unless you want to get some of the more advanced features. The rest of you, say about half of you, a little more than half of you have toyed around with it or are using it occasionally, and then only 5% of you are using it every day. I'm one of those 5%, by the way. I basically replaced, not 100%, but I've replaced a large number of my typical Google searches for information with ChatGPT or Claude AI search. Okay, very interesting. I'm surprised, though, that about a third of you have never used it, which is amazing. Okay, I've learned to do this by watching YouTube videos, putting a little commercial in the middle rather than at the end. If you want to learn more about mixed model material flow, the topic of this webinar, you have a couple options. That picture I showed you from Toyota, well, we have another workshop coming up in November. And Michael, you'll put the link up in the chat if you want to find out more about that. It's over 3 months away, but it's almost sold out already, believe it or not. I think we have 7 seats left. So if this is, if this is something that catches your fancy, check it out and grab your seat, relatively soon, because for sure it's going to be completely sold out. The other option, though, if you can't make it to Toyota, is we have a platform where we're basically presenting the same class that we teach at Toyota in an online version. And so you can see it here. It's called Mixed Model Material Flow. So that's hosted in this platform called the Lean Design Studio. So you can pursue a certificate in Mixed Model Material Flow. That's taking a series of courses, not just one, and a pretty comprehensive final exam at the end to earn a certificate in Mixed Model Material Flow, also line design, also simulation modeling. So check those out. LeanDesignStudio.com will take you to the information page, and then Michael in the chat will put up the link to the course. Okay, so what do we use today for material management, for mixed model material flow? What are the tools we use? Before we start talking about AI, well, typically MRP is used, and even lean companies. We used to have a badge in the first lean consulting company I worked for. It was a button that you put on it that said no MRP, and it had a not sign, no MRP. But people misunderstood that. That didn't mean you don't have an MRP system. It means you don't use MRP for shop floor control, is what that meant. That we have a visual pull system on the factory floor, not scheduled through MRP. But when it comes to materials, you really do need MRP. First of all, because you have a lot of items to keep track of, and you have to be able to look into the future with forecasts or actual orders, on hand. And you have to be able to communicate with outside suppliers as well, electronically. So even the great Toyota uses SAP. They're an SAP user. So MRP is basically the software tool. And by the way, kind of a humorous aside is that the rumor is that IBM created MRP software as an excuse to sell more hardware, because it was so processor intensive that you couldn't run it without buying a big IBM computer back in those days, which was probably the 50s or 60s, a long time ago. So processors are a lot more capable now. In the past, you couldn't even run MRP unless you ran it at night when no one else was using the system. Well, that's changed, but MRP is still an important tool to have. And we'll be talking about that more in this webinar. Second thing is Kanban systems. So for small parts management, people have been using Kanban for a long time. I did a webinar on error-proofing your Kanban system recently, to kind of bulletproof it, because people sometimes say, well, we tried Kanban, but it didn't work. Well, Kanban works, but you have to, have a robust process in place and follow it. So Kanban systems is something we use today prior to AI. And then we have non-Kanban delivery of material, right, to the points of use. So custom racks would be a common way of delivering certain kinds of parts like sheet metal, hoses, different oddly shaped things that don't fit into a box. Have some other custom ways of delivering that. And then we have the basic strategy called sequence delivery and kitting. So what we're talking about here is trying to deliver either one at a time parts to the points of use, like typically big and heavy stuff. You want to deliver, if you can, one at a time, or kits, sets of parts to reduce the amount of non-value added motion and handling at a station by giving the operator what they need in terms of material in the form of a kit. So the basic philosophy, which I love when it comes to kitting or sequence delivery, is that of the surgeon. So in the past, probably in the somewhat remote past, a surgeon in a hospital would have to find his or her own tools, right? Instruments. And today, the surgeon basically goes scalpel, hands out his or her hand, and an assistant puts the tool right into the hand. So there's no delay and there's no searching around. So that would be the perfect kind of model to use in manufacturing for operators. The operator says bolt, and someone puts the bolt right in his or her hand, and they can immediately install it, as opposed to having to find the part. Even if the part is in front of them, directly in front of them, you still have to find the bin. If you have a lot of them, that's not instantaneous, and then you have to reach out and you have to retrieve the part. So that's where kitting can reduce that kind of non-value added motion, all right? And then the last thing, formal delivery routes. So we typically today have formal ways of paths through the factory to deliver parts, typically on some kind of fixed cycle is what we like to see. So, and tuggers is typically the way to deliver those smaller parts. The tuggers could either be pulling a cart with a bunch of bins on it, or the tugger could be pulling a custom cart with oddly shaped parts on it built for that purpose. But tuggers versus fork trucks would be the kind of the method of choice, if possible. It's what Toyota does. And then finally, we have the huge issue of building a JIT, just-in-time system with outside suppliers. And those could be outside suppliers locally within a certain geographic area around the factory, typically with a truck, or we have overseas or farther away suppliers. But the strategy in both cases is to figure out ways to reduce the amount of inventory that we have to store for those suppliers by having more frequent deliveries with smaller quantities per delivery without driving up transportation costs. So that is the challenge. And that's not something that happens overnight. Now, when we teach mixed model material flow, this is what we teach in the workshop that we present at Toyota. We've organized the content of the training into 9 phases. Now, we could have divided it into 12 or some other number, right? There's nothing magical about 9, other than 9 is a good enough number to get some good resolution on each phase. So it kind of makes sense, but it's not too many where you can't remember them and it's confusing. So we have 9 steps that I'm showing you here. And you notice flow foundation is simply kind of a getting organized, planning, master plan, current state assessment, that kind of activity. But the very next one, PFEP database, is setting up a PFEP database. And almost all of the subsequent steps feed into that PFEP database. So we have a kind of a record for every item of how we're going to manage it. And then we go on to setting up a Kanban system that's important for certain types of parts. And then we have sequence delivery strategy. That'll be larger, heavier items with the attempt to deliver them one at a time. And then we have containerization issue, so standardizing the containers that you're using. Designing delivery routes based on a certain cycle, number of cycles per day, and where those tuggers are going to go to fit within that cycle. So there's some design required there. Other issues, conveyance methods. So for every item, we need to define how we're going to move it. Can it be moved by hand? I mean, that's an option. Just pick it up, or with a tugger, or with a fork truck, or with an AGV, or with a conveyor. We need to think through for every item how we're going to move it. And then we have this whole issue of outside suppliers that I just touched on, big issue. Not something that's ever going to be done really, but a huge differential if you can do this right. And then finally, sustaining. So how do we bulletproof this whole system? How do we keep it up and keep it running? So that's basically the course outline for the mixed model line design course. Okay, so let's talk now about some what I'm calling native AI opportunities. So this is, or another way of saying that is no code options. You being able to use ChatGPT or Claude AI. Why am I mentioning those two? No particular reason other than those are the ones I'm familiar with, but there are other companies, Google has their AI and, a lot of different options coming up. But those are the two, Claude.ai and ChatGPT are the two that I pay for and that I know. So what we're looking for here are ways to use the existing tools available to you right now, right today, to help us in developing a more robust, more streamlined, more automated, perhaps, material flow system. Okay, how can we use this? So some of the biggest ones, and many of these I have actually used. So this isn't just vaporware, where I'm speculating about the use. We've actually done this. So the first one is writing macros to automate Excel worksheets. So the earlier versions of ChatGPT and Claude were not that good on manipulating numbers, I found. They weren't that strong. They were great on language, like English language or whatever language you want to pick, but in terms of data and numbers, it was not that strong. And so we had some opportunities to improve our processes that were number-driven, data-driven, and I couldn't trust ChatGPT to give me the right answer, basically, to the bottom line. And so our solution was to ask ChatGPT or Claude, both of them are pretty good at this, to write Excel macros. Now, could I write an Excel macro myself and not use AI? Sure, maybe. I mean, I can, kind of, sort of. But for me to do the kind of things that I wanted to do would take me a lot of time, to be honest, because I don't write, VBA macros every day. And so there'd be a lot of looking up the syntax, running things, finding it didn't work, etc. It could take me hours and hours and hours to write some of these macros. But if I can just explain it in plain English and ask ChatGPT to write it, it does a pretty good job. Not perfect every time. There's usually some kind of back and forth. And that's why if you're using ChatGPT, it's good to kind of break down the process into submodules or sections. So you're not trying to debug a whole bunch of macro code, but it does a pretty good job. And I've done some amazing things. Like one of the things I did was be able to create and calculate our mixed model line design worksheet, resource calculations, tack time, and all that stuff with one click. Do all the necessary calculations and do it correctly. I was also able to use ChatGPT to take that same line design calculation spreadsheet, which is one sheet, and generate a discrete event simulation modeling model from that data, again, with one click. Now, it took me a little while to do it, but nowhere close to what it would have taken if I had to do that, try to do it myself. or even pay another human to do it, because literally the code is generated in seconds or a minute. The longest time in generating the code is just scrolling on the screen. It's pretty much instantaneously it starts writing the code. So the kind of time it takes to develop some things in Excel with some really powerful macros is much, much less. So I would highly recommend that. And that way, if you have a macro, you can actually check the code, right? If you're not sure about the output, if it's absolutely critical that those numbers be right, if you just rely on AI, you can't always be sure of that, because it's kind of a black box. You give it some information and you get something back, but you don't know exactly what happened. So there's a lot of value if you can't live with that, of having AI write macros, and I've done that a lot. Okay, next one. I've noted this is something I've just learned recently. I was curious, and sure enough, the latest version of ChatGPT, which is 4.0, and the O stands for Omni. Omni means, in addition to just text, it has ability to analyze images. So it's a multimodal. So they call it Omni 4.0. And the latest version of ChatGPT can read an Excel spreadsheet. It can modify that Excel spreadsheet, and it can create new Excel spreadsheets based on your script or your instruction. And I haven't spent a lot of time on this, but I was surprised. I tried it out, and I asked ChatGPT to create a whole new spreadsheet from scratch with some data in it, and it did. It gives you a link when it's done, and you can download that link. So if this is true, and if it does a good job, this opens all kinds of doors for example, for error checking. Let's say you have an Excel spreadsheet. You did it mostly by hand, but you want a second set of eyes. You could just upload it to ChatGPT with some instructions on what to check for, and have it do it, like more or less instantaneously. Which, so there are all kinds of options here that are open to us, apparently. Now, Claude, which is a competitor to ChatGPT, does not yet have that capability, but I think it's only a matter of time. And I think it's only a matter of time when these systems, these AIs, get better and better and better at handling data. But so far, I'm pretty impressed with that ability to, you can upload an Excel file, you can have it create one, you can have it modify the one you uploaded and then re-download it. In other words, change it. So there are all kinds of options there. All right, third thing you can do today, it says build your own material flow chatbot. Again, this is a new feature. We've been using this for a while with an app, separate app company called Custom GPT. So Custom GPT let us upload our own documents, like our own books, our own YouTube video links, any content that you have that's yours or ours, and build a kind of a private chatbot that is trained in our specific methodology. Because without being able to do that, when you ask questions about mixed model anything, the answers are going to be based on whatever the AI was trained in originally. And who knows if they were trained in our particular methodology? Probably not. So this allows us to get over that and actually train and develop a custom chatbot. So that was Custom GPT, separate company. But then ChatGPT itself came out with this thing called agents. So I'll talk about this in a little bit more detail. So you can set up an agent and essentially do what I just described. In other words, train your agent in proprietary or specific content, and then use that as a quote unquote private chatbot. So huge opportunities here as well for all kinds of areas, including training, including private company chatbot, human resources questions that are specific to your company, et cetera, that kind of thing. What next? Data mining and analysis. So again, sort of similar to the Excel functionality, but you can upload any kind of data that it can read, like it could be a text file, CSV, or an Excel spreadsheet, and ask ChatGPT to do some kind of analysis. So this is a little bit like machine learning, basically. But take a look at this, tell me what you see, et cetera, and give instructions. So that can be very helpful as well, especially when you have a lot of data. For example, and I'll talk about this in a few minutes, if we have a very large PFEP database, plan for every part, we can use AI to help maintain that. Because one of the biggest problems with PFEP is maybe you create one when you have a new project, a new line design, and then it's just too much work to maintain it, right? To keep adding new part numbers, pulling out the old ones, et cetera. All that could be automated pretty easily, I think, with some AI help. And that's what I'm talking about in the last bullet there, PFEP management and automation. We see that as a great opportunity. So all of these things that we just discussed can be done today, right? But let's look at a few of them in a little bit more detail, drill down a little bit more. So creating assistants or private chatbots that I was just mentioning. The way you get access to that in ChatGPT, number one, you have to have a paid version. Now, the paid version is not very expensive, to be honest. It's like $20 a month, I think. But it gives you access to a bunch of features that you might want to have. And if you have the paid version, you can go to platform.openai.com/assistants, and it allows you to set up unlimited number of specialized chatbots, and you give them a name and you describe their behavior and their conversational style, their communication style, and you provide specific content to them. Quite a large variety of different file formats, but you give them content to do some training. Now, I don't think you're actually training the AI. I believe, I could be really wrong about this, but I believe that every time you launch the assistant, it actually reads all those documents kind of into memory. And then when you close that session, it forgets it. So it's not actually training in the way that maybe they're normally trained. But when you're in a session with that chatbot, it has access to all of that information. So as I said, a lot of different file formats are available to do this kind of information sharing. And I think this is something we're going to be using a lot, and I think could be really valuable for you. This looks like a friendly. By the way, I'm going to be I'm going to be showing you some DALL-E AI generated graphics in this webinar too. I had a kind of a collection of them, and I kind of threw them all in here, as many as I could. And this is one where you've got a human and you've got your assistant. Except what's a little creepy about this is the hands are kind of close to the throat here. Could be slightly creepy. All right, let's go on. Another thing you can do when you're looking for opportunities for using AI is ask ChatGPT to give you ideas. So tell me, how can I use you, ChatGPT or Claude, to improve my material flow system? And it's happy to come up with ideas. So here's something I did just a few days ago. I said, hey, Claude, in this case, I used Claude.ai. So how can I use you to help manage my plan for every part database or spreadsheet? And so Claude came back with, here are 10 ways. I think I actually asked for 10 ways. I could have asked for 20 ways or 30 ways. I don't think it would have run out of ideas, to be honest. But here are 10 ways AI could be used to create and manage a plan for every part, using, and I was very specific about this, using only native capabilities. Otherwise, it's going to give you all kinds of ideas where you would have to have a software development team, right, to make it happen. Okay, so only native capabilities, and I'll just read off the titles here: data extraction and formatting, part description generation. That could be interesting if you have a whole bunch of different part numbers, but the naming conventions are not consistent. Not for the part number, but for the description. It could help you there. Categorization and tagging. Yeah, you could create a column in your plan for every part. If there's some characteristic that you want to isolate and be able to filter on, it could very easily go through and generate that for you. Supplier information compilation, as long as it has access to that information. Inventory management suggestions. plan for every part can be very powerful, especially at the beginning if you're using it for the first time, to try to identify the low-hanging fruit. I remember one company, will not mention their name, but they set up a PFEP, and then they sorted based on the biggest difference between what we should have based on our calculation of target inventory or goal inventory and what we actually have, and look for the biggest variances there. And they were able to save, it was literally hundreds of thousands of dollars. This is a big company, but hundreds of thousands of dollars in inventory reduction by just looking at those, like the Pareto principle, looking at those few parts where they had the biggest gap, where they could really, bleed down the inventory and stop buying it until they got down to the target level. So that's 5. And then gave me 5 more. So quality control checklist creation. So look at each part and come up with a comprehensive quality control plan or checklist. Maintenance schedule development. Excellent. That could be very helpful. Cross-referencing and alternatives. Identify and list compatible alternative parts that could be used as substitutes. How it would do that, I'm not sure. Cost analysis and optimization, yes, absolutely. Documentation and procedure writing. Now, both Claude and ChatGPT are excellent writers. So if you have documentation, as opposed to a human writing it, you could really take advantage of that. Now, like I said, I asked for 10. I could have asked for 20. I could have asked for a lot. So you're not going to run out of opportunities. And all of these, at least according to Claude, can be done without any special coding or special development effort, just based on what it can do today. All right. So this is a big one for me. I've already touched on it a couple of times, but let's talk about it again. So PFEP maintenance, because in our experience, PFEP oftentimes gets neglected. Once it's created, once your project is done, it's not something that gets maintained. Why not? Because it's just too much work, right, to maintain it. So maybe we can do something with some automation here. I'm sure we can. So there are a couple things that you want to automate. Number one, you want to automate data extraction. So I'm assuming that MRP, ERP, MRP is your Bible, right? It's the truth. But we want to be able to get information out of that easily so we can maintain our PFEP spreadsheet is typically what it's going to be. It doesn't have to be a spreadsheet, but that's usually what people use because it's easier and really flexible. So you can actually, you can have your IT department help you with this, but AI or ChatGPT, Claude, can write the code to build that interface if you don't have the skill to do that already, right? To be able to extract information like new part numbers automatically entered into your PFEP database, for example, that kind of thing. So AI can help with that, developing that tool so that you can maintain an accurate, up-to-date list of parts in your PFEP based on what's in MRP. Okay, next thing, the validation or data validation or calculation. Like typically most MRP systems do not have a Kanban module. Maybe some do, I don't know, but the ones I've seen don't. So you're calculating the Kanban bins, number of bins, a Kanban target inventory in Plan for Every Part, in PFEP. So that can all be automated with a script, with instructions to ChatGPT or Claude. So write a detailed script or prompt describing what you wanted to check for, and then with a single, click, basically, AI will go through and really keep your PFEP up to date, right, current. And that's the third bullet there. So even if you don't have new part numbers coming in or out, you're going to be running PFEP validation, let's say, on a regular basis. And that way, that'll take a lot of the pain out of maintaining a PFEP database out of the picture, because you've been able to automate it, and then you can really use it as a useful tool on a day-to-day basis, not just on a one-time basis, right? We're big fans of this. Now, I touched on this already, but let's look at how this would work. The Kanban quantities. So for every part number that's a Kanban item, not every part number is going to be a Kanban candidate, but for everyone that is, there's some steps that we need to go through to determine what is our target inventory, what's our goal, in terms of maximum inventory for this part at a location, right? So at a workstation, what's the maximum inventory we want to have? And then how does that translate into how many bins do we need to fit those parts? And presumably we have standardized bins. So let's take a quick look at the process. So we're going to document usage for each part from MRP. This is one of the things that MRP does. It'll calculate usage, historical usage or current usage or future usage. So we're going to document usage for each part. We're going to pull that electronically, automatically out of MRP. And then we're going to apply, or AI is going to apply the Kanban sizing formula. So there's a formula we want to use to calculate the quantity and the number of bins, number of containers. And then we're going to flag the parts. This is like a maintenance step. We're going to flag the parts where the calculated quantity or number of bins is different from the actual that you have. So there's a change that's happened. And then we're going to review that. Probably a human being is going to take a look at that and then approve the change. Now, this is what Toyota actually does, Toyota Material Handling. They have a system. It's a homegrown system. It's not using AI. It's just using straight old code. But every time they scan a Kanban card, it looks at the usage for that part and does a Kanban calculation and looks at the actual number of bins. And if the calculation is different from that, it recommends an adjustment. And sometimes it can be, you need to add another bin because we see demand going up. Or it could be, hey, keep things as they are. Everything's fine. We'll just reissue that card, reissue that bin, and we're done. Or I'm going to remove a card from the system for that part number because we see demand going down. Now, how do they see it going down or up? They have MRP, right? And MRP looks at the backlog or forecast, and it projects the usage for that part. So they're able to use that data that already exists. That's one of the things that MRP does. So very cool. Hardly anyone that I've seen actually does that, but that's what they do. And their Kanban system works. You can't say flawlessly. I mean, things can always happen, but very, 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 very well by taking this approach. Okay, what else? Using AI for mixed model material flow. So inventory management. So this is a similar thing that we would be developing with a script that we communicate with AI. So if we know what the on-hand inventory is for each part, and AI also is able to calculate the target inventory, the goal, the maximum allowed inventory for that part with a formula. If it can do that, then it can compare the two and flag the exceptions, hopefully, where your inventories are out of balance, right? Usually where you have too much. You could have too little, but where you have too much. And then in step 4, I say Pareto and do it. So Pareto means just focus on the biggest opportunities first and work your way down. But this can be tremendously helpful, especially if you're doing this for the first time. Once your Kanban system is working and you're checking it often and you have this kind of AI level automation, you shouldn't have cases where the inventory is out of balance. How would that happen? But initially, you could have cases where for certain items, you're way overstocked, for example, or you're understocked. And by being able to Pareto it, sort it, you can really focus on the lower hanging fruit and address that. So extremely powerful thing. But I said, especially during the early stages of doing this. Okay, containerization. We can use AI to help us determine the proper container size for each part. Again, I've seen companies, I'm not going to mention names, that have containerization apps that they've developed with Excel, usually, Excel macros. But the basic idea is if you've standardized your bins, like say you're allowed, this is a management decision, right? We're allowing 5 different acro bin sizes on the factory floor. Just made up a number. And you know the size, the dimensions of each bin, and you can capture part-specific information like weight and length and height and width, etc. And I said nesting possibilities. So if the part can be nested, one inside another to kind of consume less space in the bin, that's something that you might want to be looking at. Then AI can simply go through that analysis and recommend the proper container size for every part. Now, that's something you're going to have to do. Whether you have AI or not, you have to make that decision. But if you have a new product, for example, with several hundred parts, how long is it going to take a manufacturing engineer or a material flow person to determine the proper bin size for every part in that group of 100 or 200? A long time, I can tell you. Whereas if you have that information available, then AI can do that for you. Now, can it do it 100%? Usually not, because at least in our experience with these Excel tools, you can expect about an 85% or 95% of the time it's going to recommend the right container, the same container size that a human would do if they looked into it, and taking a lot more time to do that. But there's always going to be this 10% range, 10 or 15% range, where for whatever reason, because there's something about the part that's not captured in the information, right, that you have, that's an exception. And in those cases, you have to have a human, at least right now, have a human look at it and make a determination, how to store that, how to move it. So you can't expect it to be 100%, but if AI can do this in a few seconds versus a human taking at least a few minutes per item to do it, then that's a huge savings. Okay. I want to mention too, in terms of things that are happening today, this is a little bit available today, but a little bit different than just native capabilities of ChatGPT. There's a company that we're having discussions with called Retrocausal AI. I invite you to look up, that's their website as well, Retrocausal AI. And they have a couple products. One's called Assembly Copilot. The other's called Kaizen Copilot. And it's pretty much focused on a workstation at this point. But for example, the Kaizen Copilot, and by the way, this is sensorless AI. So it relies on vision or camera. And with the Kaizen Copilot, you can direct the camera to a workstation, a person doing work, and it will record that, analyze that motion, the times, the parts, and come back with essentially a Kaizen plan. And part of that Kaizen plan is ergonomics, positioning of parts, right? Organization of the material. Like, for example, if you have an often used part, but it's kind of far away, it's going to recommend probably to take that part and put it closer, physically locate it closer. So there are a lot of material related concerns that are addressed with the Kaizen Copilot. The Assembly Copilot is similar, but the Assembly Copilot will watch work being done and then create standard work definitions, instructions, like visual instructions, either kind of a heads up instructions or just simply on a monitor, and record the sequence of the work steps. So if an operator does it out of sequence, it's going to flag them. So it's more line design related concerns, but certainly Kaizen Copilot has some things that affect materials. And this is available. I'm mentioning it because it's available right now, right? It's not some kind of future. They have clients and people are using it. Okay, so we're getting close to the end here. I just wanted to speculate with you a little bit about future state. So we could spend the rest of the day speculating, about all these cool things that are happening, but I just want to mention some of the highlights. So near-term advances. So now or very soon, I would see us being able to develop material flow monitoring and adaptive control. That's kind of like what we've been talking about with Plan for Every Part, right? If AI can be looking at our Plan for Every Part spreadsheet and kind of monitoring based on the rules that we provide, right? We provide the instructions, but give us feedback, raise red flags more quickly, then that's a pretty powerful tool that's available basically now. Collaborative AI systems. By collaborative, I mean maybe if we have a sophisticated enough agent or what do they call them? Assistant then that kind of AI involvement in our day-to-day work could become more and more active, right? So for example, we might have a morning huddle, with your team, but part of the huddle, part of the members of the huddle include an AI. And in the very near future with a camera, so you can actually see you. That's not that far away, and be a participant in that huddle, right? Or problem-solving meetings, or if you have an Obeya room where you have a daily Obeya meeting, one of the members of the team is AI, is there. So that's happening pretty soon. Factory digital twins. Companies like BMW, a couple big German automakers are doing this. They're creating a digital factory that's a twin or a copy of their physical factory. And that way they can do what-if scenarios, they can do testing, they can validate their production plans. This is different from just a simulation model. I mean, it's highly detailed. And you can go on YouTube and search for digital twin BMW and look at some interesting videos. They're actually collaborating with some of these chip makers on building these digital twins. So again, that's not something in the future. It's going to get better, but that's happening now. I could envision in the future where every factory would have a digital twin if it's easy enough to build it. Right now, it's probably hugely expensive, but take a look at that BMW example on YouTube. You'll be impressed, I think. And then finally, supply chain analysis. If our AI can get access to information about suppliers, vendors, parts, lead times, freight information, if it has access to that, then it could really transform how we manage our supply chains. If it can communicate with our suppliers based on a whole lot better information and a whole lot faster information, then that could really be transformative. And I don't think that's that far away. Now, let's look out a couple more years. Again, these are all based on things that are happening now, but they're not mature yet, right? Not yet ready for prime time. So practical AI-empowered robots. So now, instead of just information on a screen, we're talking about a humanoid, actually doing work, doing things. Again, this is, it's been a vision for a long time. Now, where are we with that? Well, I'm not exactly sure, but Tesla just announced, I don't know if it's available yet, but the Gen 3, so third generation. They had Gen 2 announced in December, so it's not that long ago. And now they're the Gen 3 with improved, they call it, I forget what they call it. It's like number of points of mobility. And apparently they're like 29 is human level. And the Gen 2 had 24 or 22 or something, so approaching it. Apparently Gen 3 is even further advanced because they show them typing on a laptop in this example, if you can believe that. So that's something that's on its way. And then there's another one I just came across. There are dozens of companies trying to build robots now. I mean, lots of them. Here's another one I thought was kind of intriguing. First of its kind AI robotics company. The company is called Figure, and this is the Figure model O2, general purpose humanoid. So these are actually being used today in some factories in the United States. I believe it's like a Volkswagen factory in South Carolina or North Carolina. These are being used as assembly workers. But the goal of this company, I think, is not just assembly workers, but not just factories, but housekeepers and all kinds of different work. So that's coming here. Again, not by the year 2050. It's coming like now, right? In the next few years, I would say. And by the way, the cost is, they're trying to get the cost of these robots down to like the cost of a car, more or less. So it's not something you buy on a whim, but it's something that, people could afford. If they can afford a car now, they could afford a robot. So fully automated MMF, so mixed model material flow process. So I could see, we're not there yet. Right now we're using AI as kind of like tools, right, to work with humans. But I wouldn't be surprised if in the future, a lot of those steps in our 9-step roadmap could be completely automated. so that basically some inputs are going to have to come from somewhere, probably from an engineer, but literally push a button and get coming out the other side the containerization, Kanban plans, sequence delivery, delivery routes, you name it. Everything you want to have for a material delivery plan is coming out of there pretty much with one click. Now, AI-based plan for every part. So beyond using it as a script and a validation tool, I could see the AI could generate a lot of these columns and generate the plan for every part. As long as, again, you have the inputs maybe coming from MRP. So much more, say, fully automated version of a plan for every part that would be possible in the not too distant future. Now, beyond that, talking about MRP, I would envision AI as being able to replace MRP, replace material planning with an AI kind of logic. Right now, MRP is entirely rules-based, right? It's code. But I could see AI taking materials, taking demand information, and taking supplier information, and being able to manage materials within an AI environment, fundamentally different from an MRP environment. That remains to be seen, but I wouldn't be surprised. And then the last thing, which again people are working on, is virtual reality. All the big tech companies have come out with their helmets or their glasses, but I would envision here in the next, few years, being able to use AI to generate virtual reality simulations of some of these things we're talking about. So you could literally put on a headset and actually visualize some of these, like material delivery routes, for example. You could visualize them. Maybe something connected to the digital twin kind of concept. But the reason more people aren't using virtual reality now is it's tremendously time-consuming and expensive to create them, right? To build the virtual reality models. But if that becomes much more possible, then that's going to become used, right? Okay, we're getting close to the end here. Let's just skip over the robots and see what else we have here. So bottom line here is that I see AI within the next, 5 years of being able to pretty much automate the material flow process that we're talking about. Now, is there still a role for humans? Sure, because where does this information come from? How does it get into the system? Humans are still going to be validating it, but a lot of the steps that we do manually, if you can describe those steps in plain English, then AI can probably do it. And I think within our realm, there aren't too many things that are just intuitive. They're pretty much rules-based, right? So from that point of view, I think that what we can look forward to here is, if you do look forward to it, is automating that process of mixed model material flow to a large extent. Now, why not do that now? What's holding us back from actually making major progress here? Well, for one thing, most material flow specialists, item number one, is they're not really trained in mixed model material flow. There aren't that many courses. It's not something you learn in college. So there's a whole training, learning, I think, on the part of the humans involved, learning mixed model material flow. We're trying to do our part. We have workshops. We're sharing the knowledge as best we can, but that's something that needs to happen, because if you don't understand what's required, you can't really be too much of a helper in terms of telling AI how to do things if you don't understand it yourself. So you need a certain level of subject matter experts, right, in this to help create this. And then what would have to happen is, for each of our 9 steps, we would have to take a look at each step and train an AI. By training, I mean have documentation, documents, a script that's quite detailed in terms of how we want it to behave, what we want it to do. Written out, doesn't have to be in code, thank goodness, but it's in plain English, right, to get this to happen. And that's going to be pretty time consuming. I mean, it's going to take a team of people, a fair amount of time, right, to do a good job. Because probably you're going to be going back and forth, trying it out. It's not going to be what you want. You have to enhance the script, et cetera, et cetera. And so someone's going to have to pay for that. because I would envision this as a big project. So the Japanese word for that is kaikaku, big change, radical transformation. So people are not going to do this in their spare time, right? It needs to be a defined project that's where people are paid to do this, right? But other than that, I don't see too many obstacles to making this a reality. Even today, even with the current native capabilities, with all the things we've discussed in this webinar, just making it happen, testing it, getting it working is going to require that kind of effort. But most importantly, you have to have a subject matter expert that knows how to write those scripts and knows how to give AI the proper instructions on what to do, which is not a given. So, summary, end of webinar. Potential for AI to fully automate the mixed model material flow process is vast, with current and anticipated AI capabilities covering almost every aspect of the methodology. While humans would still play a critical role, we're saying, in providing initial data and overseeing the process, AI could handle the bulk of analytical, design, and optimization tasks. So, again, how fast this happens, don't know exactly, but it's not the year 2050, right? It's somewhere in this decade. I would say that's going to happen. All right, so that's it. Just a quick reminder, there's the link. So leandesignstudio.com, mixed model material flow. If you want to find out more about it, that's the November class coming up. As I said, we have, I think it's 7 seats remaining as of now. We will be doing this again, I expect in 2025. We haven't set those dates yet, so probably by October we'll have those dates. And again, if you want to do this on your own, we do have the online course. It's called the Mixed Model Material Management Certificate Track. So it's a number of different courses that you have to take and pass. And then there's a comprehensive final exam at the end. You can sign up for a month-to-month membership in the Lean Design Studio or an annual membership, save some money, and that's leandesignstudio.com. So there we go. So thanks for sticking around, and I hope you found this engaging.